And without further ado, I'm going to introduce Zainab, who's rather spoiled my introduction, having announced that she's never spoken at the London Scala User Group, having been an organizer of it. So that rather took my thunder out of what I was going to say. But who here's ever worked with streaming? Who here hates working with streaming? Well, clearly you haven't met FS2 then, have you? So, to take away the pain, Zainab is going to show us how to do it properly in a true functional style. So I'm going to hand over to Zainab to show us how to do it.
Thank you very much, Rory. Okay, so I'm going to be speaking to you about streams and FS2. And the first question I want to ask you actually are, what are streams? Now you might imagine if you're coding streams of data, maybe you have streams of events if you're designing event-based systems. Maybe if you work with Unix and Bash a lot, you might think of like the pipe operator, right? Streams, file streams like that. Yeah, you might also think of streams if you're working in Java, like the file stream. And it's really hard actually to kind of categorize all these things and put them in the same bucket and talk about streaming problems. We have a very nuanced notion of what streams are. They're kind of these things which flow. Now we have streams in the real world as well, right? As you are trying to enter this building and trying very hard to get through security, you were streaming in. When you later go and get pizza, hopefully you won't do it all at once. You will be forming some kind of a queue. We're British, we're polite, we do that. And you will be forming a stream. So there are streams in the real world as well. And we can describe those streams in code using different streaming libraries. And I say the word describe because streams or streams with FS2 are not the only way of describing a problem. Right? We could, for instance, describe a stream of events using a loop. We could try and use a recursive function. But it turns out that using streaming libraries and streaming frameworks like FS2 is a much more elegant way of doing so. So instead of trying to answer the question, what are streams, because we can give tons and tons of examples, and we will, we're going to ask a different question. We're going to ask what streams are for. And maybe if we ask this question, we'll be able to find some new use cases for streams. So not just the typical use cases that we can think of, right? Not just streams from files or streams of events. We will look at those. Maybe we can find some new applications to streams within our code. All right, so this is what we're going to do. We are going to look at some examples of streams. We're going to look at examples of event streams and also data streams. And we're then going to look at more examples. We're going to look at examples of streams when working with databases and also streams when writing web servers. And we're going to look at even more examples. We're going to look at some more esoteric ones of how we might use streams when we're designing a heartbeat and also when we are designing a test framework. And as we do each of these things, as we look at each of these examples, we're going to try and ask the question, okay, well, why are streams suited to this problem? Are streams suited to this problem? And maybe if we do that, we'll be able to discover other use cases for streams. So to help us do this, we will have a few people and also non-people. I'm going to introduce some cats. So the cat on the left there is called Popcorn. She is very cute, and you will see her in some of the code examples. The cat on the right who is hiding is called Mao. He is my cat. He is also very cute. And finally, you have me. So I'm Zainab, and I am very interested in streams. I've actually been teaching FS2 for quite some time now. And in teaching fs2 and teaching stream processing, I've helped people reason through stream execution and discover new mental models of thinking about streams. And I also have a book on streams, which you can check out. I'll share a link later. Okay, so first let's take a look at streams of events. Now, you can think of many different kinds of events. Some examples that you might encounter when you're coding at work are things like messages in a Kafka topic. If you're subscribing to Kafka, you're consuming these messages, you might think of these messages as events. Or let's say that you're designing a game. You might think of and mouse clicks as input events as part of your game. So we're going to take a look at a really, really simple example of an event-based system, and that is an Echo app. So this is a little command line application. We type a name into it. It's going to be the name of one of our cats, and it is just going to echo that name back, preceded by a little cat emoji. So this is a really, really simple program. I'm going to show you how it's written, but before that, I want you to just take a moment to think about the different ways that you could write this program. Now, we could write a loop, right? You can imagine some kind of a while loop. That would involve probably some mutable state, depending on what else we were doing in this application. Let's say that we really love functional programming, we all do. We might try and write a recursive function instead. But that recursive function would get pretty gnarly if this was a bigger application. So instead, we're going to use fs2. And this is what our code looks like. It is just 4 lines, so it's very simple. First of all, we are using the fs2 IO package to read from standard in. We are then going to take our input and map over our input and prepend a little cat emoji. And then finally, we're going to do something called piping and take our input and pipe it into standard out. And then we have this little compile drain block. Now this thing returns you a cats effect IO, and if you know how to use those, you'll know how to take that IO, plumb it into an IO app, and run the code, and it will give you the demo that we've just seen. But how does it actually work? I mean, it's really hard to think about streams, isn't it? Like under the hood, we might think, well, let's say we might imagine these lines flowing through our stream, right? But just that mental picture of lines flowing doesn't really give us a good idea of how our stream operates. And that's a problem because let's say that there's a bug somewhere in our code and our application behaves in a way we don't expect. We actually do need to understand how it operates, right? We do need to understand how it works. In event-based systems as well, now this is a really simple one, but let's say, for instance, in a more complex system, we might be receiving many, many more events, and we might be receiving them more quickly than we can actually process them, right? Let's imagine that I can type at an inhuman speed. I might be typing these cat names into my terminal really, really fast. How will our application be able to keep up? These are really difficult questions to answer unless you actually really understand the streaming framework that you're working with. So on the one hand, this code looks really simple. On the other hand, it might be a lot harder to understand than if it was just a loop. So while the concept of flowing is, while we might have an intuition that we have these lines that flow through our stream, that intuition isn't a very good one. Thankfully, with fs2, we have a different model that we can use. fs2 being a streaming framework in the type level ecosystem. Okay, so this is how we're going to think about our fs2 streams. Our streams are composed of stages. I said there were 4 lines. You can imagine in this stream, maybe there are about 3 stages. We'll see them in a sec. A stage pulls on the stage upstream, and that upstream stage may output an element. And if this stage receives an element, it might do some processing, and it might output that element downstream. So I said that our example is just 4 lines, and we can think of it in terms of 3 stages. We can think of it in terms of as many stages as we like, but the stages that I think it should be composed of are this standard in stage, a map stage, and a standard out stage. And as our stream executes, we can think of standard out pulling on map, map pulling on standard in then outputting an element back to map, and then map outputting an element back to standard out. So we have this kind of pull-based execution, which causes our stream to run in a loop. Now that's actually quite wordy to describe. But thankfully, we don't need to describe it in words. We can actually just draw a diagram. So here you can see that we have these 3 stages, standard in, map, and standard out. I want you to read the diagram starting from the bottom right, where the big black dot is. We're going to describe a pull in this diagram, the concept of pulling with an upwards arrow, and the concept of outputting with a downwards arrow. So we can see here that standard out pulls on map, map pulls on standard in, and standard in outputs an element, the first element being mal. And then map then adds that cat emoji and outputs mal again back to standard out. And then this process repeats, right? So standard in pulls on map, which then, standard out pulls on map, which then pulls on standard in, and we see that popcorn is outputted. And I'm not sure if you can see, but at the end, we've got another arrow, right? So standard out pulls again on map, which pulls again on standard in. And then we don't have any elements because we're just waiting. So we're waiting for input from standard in. So this model now is a different kind of model than our intuition, right? It's a better mental model because it allows us now to predict what is going to happen if there are any bugs in our code. It allows us to predict what's going to happen if, for instance, we receive too many events as well. Let's say that I'm typing really, really fast. Well, that doesn't actually matter to our program, right? It's only going to go as fast as it goes. If I type more events than I can actually process, I'm going to need to have some kind of a buffer somewhere early on, such that when I pull on my standard in stage, I'm actually pulling off that buffer. So we can see that streams, at least fs2 streams, they're good for handling events. They're good for handling events because they let us describe the event handling process in a very clean way. What else are they good for? Well, we said we'd have a look at some problems in data, right? So the reason why we care about streams in data processing is that often when we're dealing with large volumes of data, we can't actually fit them in memory. So we need to operate on them in small chunks. I want you to imagine that I've got, as our data processing problem, I have an input file. And this input file has a list of all of my cats. And it's also got a list of all of my friends' cats. And I have lots of friends, and they have lots of cats. So this file, you're only looking at a small snippet. In fact, it's around 2 gigs in size. And you may not want to actually fit that all in memory. OK, so our data processing problem. We want to take this file, this input file, and we want to output a file with just the cat names prepended by our little cat emoji. So we actually want to strip the comments as well from this file. OK, so how might I write this? Let's go straight to our fs2 implementation. So I can use the fs2 files package. It's a bit longer, this code now. It's around 3, 4, 5, 6, 7 lines, let's say. And it's a bit more complex. So we're reading the lines. We are filtering all of the lines that start with comments, so we're filtering those out. We're then mapping and adding our cat emoji. And then we are interspersing that with the new line character. We are then re-encoding it as UTF-8 and writing it all out. So what's really cool is that I can just read this and understand what it's doing, get a really good high-level intuition, even if I don't need to think precisely about all those pulls and outputs, right? If I needed to debug it, I could go and I could think about the pulls and outputs associated with this code, but I don't need to. So streams with fs2, they're actually really composable as well. Well, I said I could think of it in terms of pulls and outputs. Let's say, for instance, let's say that we wanted to figure out a bit more about how this code was working. In particular, we wanted to see how the mapping was working. We could also think of this in 3 stages. It has an upstream stage, which goes and gets the input, a map stage, which adds this emoji, and a downstream stage. And we can also draw a picture for that. So the way that this operates is actually really, really similar when we look at it to our event case, right? In the case of our events, we were actually reading from standard in, but now we're reading from a file instead. The only difference, perhaps, is that sometime at the end, when we reach the end of this file, our stream terminates, and we've indicated that by a little green tick mark. So streams are good for data as well, right? They're good for data because they allow us to stream small chunks of data instead of processing the data as a whole. And we kind of think about data processing slightly different to events, right? Because usually when we think about data processing, we have all the data there, right? We don't need to wait for the data to appear. But actually, as we've seen in terms of the underlying operation, they're both pretty similar. So we can use streams to describe event handling, and we can use streams to describe data processing. Let's take a step back and think about what's similar about these 2 cases. Well, maybe there's infinite loops, right? When we're trying to handle events, we've got an application that might never terminate. If we're reading reading data from a file, we do have a program that terminates though eventually, but it does need to do a lot of stuff first. Maybe it's the incremental aspect, right? When we're dealing with data, we're actually trying to build an incremental pipeline, so something that operates on chunks of data at a time. Maybe it's the fact that we have elements, right? In both cases, we had an element. You could think of that as a line, right? We were reading a line from standard in. We were reading a line from our file. So maybe it's the fact that we have elements. Maybe that's it's those things that we should look for when we're trying to apply a stream. Okay, so we're going to look at some other use cases, which will kind of fit into the same. First, let's take a look at databases, streams in databases. We're going to have a table of cat names. And imagine that the table contents are quite similar to our file contents. We're going to have Mao, Popcorn, and a load of other cats inside our database. And the thing that we want to do, is to stream our cat names from our database into standard out. So stream them to our console. Well, there are very many libraries in the type level ecosystem for working with different things. And we're going to use a library called Doobie to stream our data from our database. This is how you might write a very simple query with Doobie. And you can create an fs2 stream just by calling .stream. And what you will get back is a stream of cat names. And you can work with that stream of cat names in exactly the same way as we have seen our stream from a file or our stream from standard in. So we'll just take our stream, we'll map over it and append this cat emoji, and then just put it through the standard out stream that we saw earlier. So using just this code, which is really simple code, right, really concise code, we can now stream from databases too. So the more interesting thing about databases, right, is that when we're constructing this stream from a database, it doesn't quite fit a data problem or an event problem. It is a data problem in the sense that our database has huge volumes of data and we are streaming things, we're streaming small chunks, right? But let's say that our database was overloaded or our network connection was a bit slow. We would actually be stopping and waiting to receive that data in the same way that we might wait for events. So it's kind of a mixture of both this data and event problem. But we can describe it in exactly the same way. Right. Let's take a look at another example. Let's take a look at web servers. Right, so I want you to imagine now we have a web server and we are hosting it locally, and I can go and call it, and I call it with a name, and it's just going to give me back that name prepended by a cat emoji. So I call it with Mao, and it's going to just return me this emoji Mao. I call it with popcorn, it's going to return me popcorn. Now, if I wanted to write this code, or rather code this up using fs2, I would write something like this. So I would use a library called HTTP4S. I would describe something called a service in HTTP4S, which has a get endpoint. And that just takes the name, which is part of its path, and returns an OK with that name and the cat emoji. And I would just take the service and I would use something called Ember, which is within HTTP4S to build up a server and then plumb this code into an IO app and run it up, and I would get the service that you just saw. But there's no stream here, is there? Right, where's the stream? Yeah, we are. We're streaming the response, for sure. We're streaming the requests too. Let's say that we actually decided to do some more advanced stuff with this. Let's say we decided to do stuff with WebSockets. We'd be streaming those. There are actually a ton of streams underneath this code. And if you are at all looking for inspiration on what to use streams, I strongly encourage you to just check out the HTTP4S codebase. You will find that streams are used in practically every single file there. To do many different things. And there are lots and lots of other streaming constructs as well. Okay, so we're going to build a very, very simple model of the way that this might work. Let's imagine that we're reading these requests, very, very basic model of HTTP, right? We're reading these requests off some socket. And then we are using our service to handle these requests, right? Produce a response. And we're going to write that response. This is how we might write that using fs2. So we would repeatedly evaluate some effect to read the next request. We would then call something called par_eval_map and handle the request. And finally, we would evaluate another effect to write the response. And what's important about this code is that we are handling these requests concurrently. So in a real world example, right, if you had a web server, you would want multiple people to be able to call it at the same time, right? You would not want to handle your requests sequentially, and hence we can add concurrency into the mix. So that's what this par_eval_map unbounded does. It handles stuff concurrently. Well, how do we think about concurrent programs? They're kind of complicated, right, in general. If we have any kind of concurrency, we have the ability to have lots and lots of other concurrency bugs. So how does fs2 help us with that? Well, this code operates in pretty similar ways to the code that we've seen so far. So we can also draw a picture for it. And we can think about how the code operates in terms of pulls and outputs, but in a concurrent system. Okay, so we have 3 stages. There's the read stage, where we're just reading stuff off our socket. That has to be sequential. We've got our service stage, in which we're handling stuff concurrently. And we have our final write stage, which is the thing that's writing our responses back. Okay, so our write stage pulls on our service stage to say, hey, I want something to write. I want a response. Our service stage, then if we have a look at it, we see that it pulls on our read stage, but it actually pulls multiple times, right? So we pull an element, we pull Mao, and then we pull another one, we pull popcorn, while we're still handling the request for Mao. So while our service is processing and producing this text for Mao, it's already pulled the text for popcorn. So the way to think about this, right, is that we have several sequential processes which are happening concurrently, right? The process of write pulling on the service, that is sequential, right? We can think of those outputs in a sequential manner. Also, the process of the service pulling on the read stage and the read stage processing itself, we can think of that as something that's sequential. But the actual handling itself that the service does, that is concurrent. So by structuring our program in this way, we can kind of think of how our stream is composed of different things which are happening concurrently and different things which are happening in sequence. And that really helps us when we're reasoning through concurrency problems. So streams are actually an excellent tool for concurrent processes. Okay, so we've seen how they can be used for databases and also for web servers, right? What's similar about these cases? Well, they both had some effects, right? We've seen effects before, but we've seen them in a bit more detail here, right? We're reading stuff off a socket, or we are querying a database. In our web server case, we had some concurrency, right? We saw how fs2 was good for helping us handle concurrent processes. In both cases as well, it was a bit hidden from us, but we had resource management as well. If we opened a connection, for instance, to our database, that connection would need to be closed. Even if there was an error that occurred, our connection would still need to be closed. And streams actually help us with that as well. The same is true for if we have a web server. We are opening sockets. Those need to be closed as well. So streams also encapsulate resource management. Okay, we're going to look at some other examples now. And maybe by looking at a few more abstract ones, we can figure out what else we can apply streams to. So we're going to look at an example of a heartbeat. And we've seen cats in all our examples, so we're going to heartbeat. Our heart is going to beat with cats. We're going to just write a really simple application which will print a heartbeat of a cat emoji to the console, and it will do that every second. We can imagine how we might do this in a loop, right? You might be able to write a loop which just sleeps for a second and then prints to the console. We're going to use fs2. And this is what our code might look like in fs2. So we're repeatedly evaluating an effect, which is the print line. But we're spacing it out by 1 second. So we're using something called spaced. And what that does is that it just inserts a 1 second delay within our pull and output process. So if we actually try and draw this, if we imagine actually that this is split into 3 stages, there's the upstream, or rather the print stage, the space stage, and the downstream stage. We can think of how this operates in terms of pulls and outputs, right? So our downstream stage pulls on the space stage, which pulls on the print stage, and that actually evaluates some effect and prints to the console. You can see the effects at the bottom. And then it outputs unit. So we thought that we were actually working with elements, right, when we were working with streams, but actually this is a stream of units. And then after outputting unit, the downstream stage then pulls again on spaced, and now the space stage waits for 1 second before pulling on its upstream stage. So we can see that by using a stream, we can also structure our computation in a certain way. So streams are really good for working with time. They're really good for working with time and also structuring computations within time. And that's a really interesting point because we didn't have any elements really in this case. Maybe we could have described our heartbeat as an element, a string of a cat emoji that was going through our stream, but we didn't need to. Well, what else are streams for? So I'm going to give you, actually this is pretty much a real world example. Let's imagine that we have a function, add cat, which is going to add a cat to our line, and we want to test this function, right? We might write a few tests. These tests are written using a testing framework called Weaver, which is based on fs2. Recently added to the level ecosystem, by the way, if you weren't aware. We're going to write a couple of tests. We are going to test that if we add a cat to the string Mao, we will get a cat emoji followed by Mao. We also want to test that our add cat function ignores empty lines. And I want you to imagine that our add cat function actually takes a really, really long time to run. Right, so actually, adding a cat emoji is not a trivial thing. It takes several seconds. And imagine what it would be like as a developer to run these tests and have to wait not only several seconds for the add cat test to complete, but also for the ignore empty lines to complete. You would want to run these tests concurrently. And thankfully, Weaver does that. It does concurrent testing. So if you were to run these tests in Weaver, you would get an output that looks like this. You would see as the tests ran, you would see which ones passed and failed. So the plus means add cat to Mao passed. The minus ignore empty lines means that one failed. And then at the very end, you would see a log of all the failures. Well, let's think about how we might use fs2 to code up this problem. We might want to model our tests as a case class, right? Our tests have a name and also some kind of a task associated with them. And that task can succeed or fail with, in this case, a Boolean. We can define some function to run that test, right? So we run the test task. If the test task succeeded, well, we can print it with a plus sign. If it failed, we can print it with a minus. And we can return some test result. And then if we wanted to run these tests concurrently, well, it's as simple as using the construct we just saw, right? So using the par-eval-map operator that we just saw. So all we need to do is plonk these tests into a stream, use par-eval-map to run them concurrently, and then finally just plonk this entire stream into an IO app. And that's all we need for our concurrent testing framework. We did want to print the failures out separately at the end, though, right? So let's do something else with our test result. Now, our test results, so they're a list, but we can convert that list to a stream, and we can perform list-like operators on it, right? So we can filter out the ones that have succeeded. And then we can just map over our results that have failed and print the name of the result. And so you can see that if we do that, we can actually then print out our list of failures at the end. So what are streams for in that case? Well, we use them to run our tests concurrently. And in running our tests concurrently, our tests were really just tasks, weren't they? They were tasks which were represented as effects. So what we were actually doing was that we were structuring our effects in a certain way. And that really gets us down to the heart of what we can use streams for. So really, streams themselves are tools for describing control flow. They are tools for describing a different way of structuring our programs. And those ways lend themselves to describing things like incremental pipelines in data or event handling processes. But really, we can actually use them to structure any program. So now next time, whenever you see a problem that you have, you can think to yourself, okay, well, can this problem be best solved with a stream? Can I try and use fs2 to structure my effects this way? There are certain candidates of problems which you might have. You might have, for instance, loops, right? If you see a loop which is evaluating effects, that's probably a good indication that you should start using fs2. If you have something which is infinite, then that's probably another good indication. But in fact, even if you have just general control flow, fs2 might be a good fit for you. Okay, so where might you go next? To learn more about fs2 and about how you can use it with control flow, there's a great talk by Fabio on declarative control flow with fs2. There is also a book that you could read. I mentioned it in the beginning. It is called Functional Stream Processing in Scala. It's early access currently, but it's still pretty comprehensive. So please take a look, and you can get 50% off if you use that code. So thank you very much.
Right, any questions? Okay.
Hello, thanks for the talk, it was amazing. So one question, what's the difference of using a map operation as opposed to a through pipeline? A pipe, sorry.
Yeah. So through is actually, I mean, it seems mysterious, but it's actually just anything that you use if you have a function that goes from a stream to another stream. So if I just have a function for which its signature just takes in an input stream, let's say it does some stuff with that stream. It might map over that stream, filter that stream, do other things, and then return the stream again. I can just use through to kind of to call that function. So I could actually take the code which was written in through and rewrite it to just doing function calls. And it would look worse, but it might be easier to understand if you hadn't seen through before. Map, on the other hand, what that is doing is you can think of that in terms of pulls and outputs, right? So that's pulling an element, mapping over it, so producing, or rather constructing something else, and then outputting that element.
Thank you. I have another question. Could you highlight the difference between map and eval map?
Yes, I can. So eval map, you use that one for when you're working with effects. So if I have an effect well, put it more concretely, because we always use streams with I/O. If I have something which is an I/O or in an I/O monad, I would use eval map. If, on the other hand, I had a completely pure operation, I would use map.
Thank you. Is there any difference in using one or the other in terms of the chunks of the streams?
Oh, that's a really good question. So actually, chunking is something that I didn't describe. And I will do so now. We had some slides here which lied. Oh, you're supposed to be shocked. I lied. Let me find them. So here's our data slide, right? So we said, okay, I was trying to describe how fs2 streams stuff from files, and I said it does it this way. In fact, if you think about it, if I had a really, really big file, I wouldn't want to stream stuff line by line, right? In fact, what fs2 does is that it reads an entire chunk of the file. So it reads a large number of lines, bytes, whatever it is that it is consuming. And those are the things that go through our pipeline. Now, when we're evaluating effects, we actually have to be very careful when we're working with chunks to make sure that we don't evaluate too much before something breaks. So eval map does do stuff which is slightly different. If you want to learn more, then I recommend going to, reading my book. But also, there's a website that you can go to called Aquascape, which I'll send out an email later which has a description of the exact differences in the behavior, which I also authored that website, so you can come and ask me.
Thank you very much.
Thanks.
Yeah, thank you. I'll try real quick. Does fs2 have any ways to handle stateful stages? Like, can we build a state machine with it?
Yes, you can. So depending on what you wanted to build, you could use, there's Gosh, so there's an operator which you can use which can kind of build everything. I think it's called map accumulate. There's also eval map accumulate. It's got quite a long signature, but if you look into it, you can see how, yes, you can basically map over with some state. So you can do things like folds, things like reduces quite simply, but you can also develop more complex operations using that. So yes.
Okay, second short question, sorry. Can we have cycles in fs2 stream?
What do you mean by a cycle?
By this I mean that the output of the stage could be like input of itself, for example, or something like that.
So if you wanted to do something like that, you would use something called a channel. Actually, maybe think about it even simpler. So what you would do is that you would have some kind of a queue or buffer, right? So imagine that what you're doing when you're outputting is that you're actually outputting something to a buffer. So your entire stream is something that just pulls and outputs to a buffer. And you could then have another stream which would be pulling off that buffer. So you wouldn't really think about it as a snake eating its own tail type thing. It would be much simpler to reason about if you just thought of that intermediary buffer.
Yeah, it's probably also easier for back pressure. Yeah, all right. Yeah, fair enough.
Yes.
Thank you for
Thank you very much. That was really interesting. I guess a more high-level question combined with maybe a low level. So, would you recommend any specific tips or common solutions to problems where we deal with very large volume of data within your streams, but also what we want to ensure quite low latency? And the question is kind of twofold. Like, is Scala probably a good tool for such use case, or you would probably switch to something like Rust or C++ instead?
Yeah, that's a really good question. So usually in those cases, the things that are limiting you are not actually necessarily even your application. It's usually the kinds of machine that you're running it on, right? When you're actually having something which is high throughput, it's high I/O, right? Usually if you've got that much I/O, it's not actually your application code which is a problem. I found that fs2 is pretty comparable. You can find benchmarks. You can also do your own tests as well. So yeah, I essentially say that.
And there was one last question over this side.
Hi. In terms of observability, is there anything that allows you to observe your stages and measure how many stages you have, how long do the stages take, and so on and so forth? What was the solution?
So that's actually something which is a pretty interesting question. So there isn't a direct integration yet, I believe, with fs2 and stuff like OTel4S. There are a few nuances with it. I believe, though, that if you just think about your stream as, let's say, eval mapping, and you've got your I/O effects, you can trace those I/O effects, right? So you can take a look at the tools which are just in the type level ecosystem, right, for tracing, and use those on your actual I/O operations as opposed to thinking about it in terms of fs2 and stages.
Cool. Thank you very much. A big round of applause for Zainab.